Good morning or afternoon, everyone, and welcome to today's webinar. My name is Marie Latulippe, and I'm the Director of Science Programs at the Institute for the Advancement of Food and Nutrition Sciences, or IAFNS. And as we get started, we wanted to provide you with a little bit of background on IAFNS as an organization. So we are a nonprofit focused on advancing food and nutrition science for public benefit. And what we do is we connect our tripartite membership, and that means individuals from government, industry, and academia, to support collaboration and to catalyze knowledge. IAFNS also funds actionable research, and that research is conducted by external researchers selected through a competitive and open process. And all of our funded projects are noted on our website, so please take a look there if you're interested. IAFNS advances food and nutrition science for public benefit by convening these experts across sectors to engage in dialogue. And the way we conduct our work is by leveraging pooled funding that's combined with in-kind contributions from both the public and the private sectors. Hopefully, as you registered, you noted that IAFNS is an approved provider of credits by the Commission on Dietetic Registration. So we'll be providing those of you who are interested with access to the certificate after today's webinar. And to bring you this webinar today, we collaborated with colleagues at the NIH Office of Disease Prevention. I'm pleased to turn the program over to Brahma Kautha, representing NIH ODP, and she will introduce herself and kick off the program. So Brahma, if you'd like to join us.
Sure. Good morning, everyone. My name is Brahma Kautha. I am a health scientist in the Office of Director, Office of Disease Prevention at NIH. I am responsible for promoting collaborative research projects and leading trans-NIH disease prevention efforts in nutrition, obesity, and physical activity areas here. The Office of Disease Prevention is a part of NIH Office of Director under DGAC, also known as the Division of Program Coordination, Planning, and Strategic Initiatives. Next slide. So the mission of our office is to improve public health by increasing the scope, quality, dissemination, and impact of prevention research supported by NIH. Next slide. So a quick note on logistics. For the webinar, you'll see a box for questions on your control panel, as shown on the screen. We encourage you to type your questions here. The questions are only visible to the webinar organizers and not the other attendees. After the presentations, we will bring the questions forward to the speakers for a dialogue. Next slide. Okay, so let's start by introducing our first speaker today, Dr. Hayley Young, who is an associate professor in the Department of Psychology at Swansea University in Wales, UK. Her primary area of research concerns the influence of nutritional products and dietary regimens on cognition, mood, and brain functioning. So let me turn the platform over to you, Dr. Young.
Okay. Can you see my webcam now? Just checking.
Yes, not your presentation yet. Yep. Now, yes, we can see now.
Okay, so thank you for inviting me to speak today. Just my disclosures to start with. So I am a scientific advisor for IAFNS Cooperative Health Committee, and I have received funding from various food industry manufacturers. Okay, so today I'm going to talk about some of the main issues concerning cognitive test selection in nutrition research, briefly outline previous attempts at resolving these issues before moving on to some work that we've been conducting to try and come up with potential solutions to these issues. So first of all, I think it's worth noting that there is increasing consumer demand around food products, diets that benefit cognitive health. So the IFIT survey in 2023 indicated that psychological outcomes are amongst the top sought benefits now in regards to food, beverages, and nutrients So consumers are looking for things like increased energy, improvements in sleep, brain functioning, including cognition, and also emotional and mental health. So it's even more important that we are able to establish a solid scientific basis for any sort of public health recommendations that we make in this space. So in that regard, the Dietary Guidelines Advisory Committee addressed numerous questions in regards to cognitive health, which I've outlined here. So lots of them concerned sort of child development and neurocognitive development, omega-3 fatty acids, those kind of things. But the one that we've been most focused on concerns dietary patterns consumed and neurocognitive health across the lifespan, including the possibility that consuming particular nutrients and diets might be able to help in the prevention of dementia and cognitive decline. I think it's important to address this question because it does feature again in 2025. So the issues concerning cognitive test selection and stuff really do need to be sorted out because it does seem to be a question that needs to be answered. So in 2020, the committee concluded that currently, as it stands, there's actually limited evidence to suggest that consuming dietary patterns like those that include fruit, vegetables, unsaturated vegetable oils, nuts, etc., can actually prevent the onset of cognitive impairment and dementia. So what this basically means is that there's some evidence to suggest this is the case, but that evidence is limited. And one reason why it's limited is because of the heterogeneity in cognitive test selection. So this is a quote that was taken from the published report. So as we can see, there were numerous sort of limitations that came up, but one of the main ones was that there is such variation in cognitive testing methods, and that it's unclear sometimes how reliable and valid the cognitive tests are that are actually being used in these studies. So I think it's worth noting that across the Atlantic in the UK, so second is the advisory committee to the UK government. And in 2018, they addressed a similar question regarding diet and dementia. And they concluded something very similar, which is that given the wide variety of tests that tend to be used in this space, it's really, really difficult to synthesize evidence and therefore make any sort of public health recommendations. So when you've got two completely independent committees across the Atlantic coming to similar conclusions, I think that as scientists, we really do have to accept that this is proven to be a real impediment to making public health recommendations, and that we should really try and resolve these issues if we can. So looking a little bit more closely as to what some of the concerns were, the first concern was that sometimes some studies have relied solely on subjective cognitive decline measures. So these kind of measures, or questionnaire measures, how to cognition in general, tend to rely on individuals having insight into their own cognitive functions. And unfortunately, people are not always the best at reporting these things. So there tends to be low to moderate associations with actual cognitive functioning when assessed behaviorally using a cognitive test. A second concern is around test sensitivity. So often in this literature, you will come across tests like the mini mental state examination. And these are pretty crude measures, really. They ask questions like, what day of the week is it? So they're only really sensitive to, full-on dementia, rather than the more subtle sort of changes that you might get in response to diet. So test sensitivity is a bit of an issue. There tends to be a lack of standardization regarding how cognitive tests are reported. So quite often in this literature, and I come across this a lot, basically people will name the test that they're using. So for example, we measured episodic memory using a word recognition task or something like that. And they don't really provide any sort of information in regards to what that test actually involved. So just to illustrate why this is really important, it's because producing a word list for somebody to remember is a fairly straightforward thing to do. Most people can do it. However, if it's not reported the kind of test that was, so for example, were participants required to recall those words immediately or after a delay? How many words were presented? Were there 10 words? Were there 30 words? How fast was the presentation? Because that's going to influence how well a person's able to remember it. Through what modalities? Were they presented on screen? Did participants listen to the words? Were there abstract words or were they concrete words? Because that has a major effect on how memorable words are. Okay, so abstract words, things like truth, peace, are much more difficult to remember than concrete words like table, clap. Okay, how many letters were there? How many syllables did they have? How frequently did they occur in the English language? And of course, if there are repeated testing sessions, how were things like practice effects taken into account? Okay, so all of these things are really important when it comes to accepting the validity of a particular measure. But unfortunately, there's a lack of standardization in how tests are reported in the nutrition literature. And a final concern that came up was to do with composite or global cognition scores. So I've just pulled out two references here from the Dietary Guidelines Advisory report. And both of these papers, they produce global scores, which involved combining individual tests together, producing a Z-score and calling this global cognition. And that was then finally a measure. But what you can see is that actually that composite score comprised some very different tasks. So in the first one, we've got a test to do with reasoning, immediate memory, and verbal fluency, which involved producing words that began with S and animals. Whereas on the second one, it was a delayed word recall task, which had 10 words as opposed to 20, digit symbol substitution test, which is to do with speed of information processing, and word fluency again, but this time for the letters S, A, and S. Okay, so you can see that if you're trying to compare across these two studies, you're actually comparing apples and oranges. Okay, because global cognition is not being the same thing in each of these studies. Okay, so those are the main concerns that come up in the Dietary Guidelines for America report. But I think it's worth acknowledging that this is not really a new concern. So over the years, I would say sort of every 5 years or so, there's been some attempt to deal with this particular problem and make recommendations in regards to tests that can be used to assess the effects of diet. The first one came out in 2004, so we're talking about nearly 20 years ago now. This was the past claim report. And since that time, sort of every 5 years or so, there's been articles that try to recommend which tests are valid, which tests are the best to use in this space. Unfortunately, not a lot has really changed over those 20 years. And as we could see from the committee's conclusions, both in the UK and in the States, that this is still presenting a problem for synthesizing evidence in this area. So rather than produce another paper that made quite explicit recommendations to what tests to use, we decided to take a bit of a different approach. So our approach was, first of all, to provide a synthesis of all of these existing perspectives and try to identify areas where these previous expert groups, areas that they agreed on and areas that they perhaps disagreed on. We then chose to engage a number of stakeholders who tend to need to engage with this literature in order to make recommendations or approve claims, etc. To understand from their perspective what they think could be done in order to try and advance science in this area and eventually, hopefully, deal with some of this heterogeneity that exists. So, first of all, the areas of agreement. So they did agree on some things, which was nice. So they all gave some really well-known examples of particular tests that can be used in this space. So the trail making task, this is a task that does come up quite a lot in the literature, has to do with speed of information processing, word list recall, and also continuous performance tests to measure sustained attention. They all agreed that these tests really do need to be targeted towards the population. So if you're dealing with children, as opposed to adults, you're obviously looking at selecting different types of tests. But if you're dealing with an older population, then perhaps you don't want to be giving them a word list of 30 words to recall. And you may only need to use 10. And tests like the Billy-Better examination, as I mentioned, are probably not that sensitive to normal age-related changes in cognition, as opposed to dementia. They all agreed that test sensitivity to diet is really, really important. So in regards to this, we tend to think of fluid versus crystallized intelligence. So fluid intelligence is your ability to take in new information, manipulate it, do things with it. A crystallized intelligence, on the other hand, concerns a lifetime knowledge that has been acquired. So in general, tests that measure fluid intelligence as opposed to crystallized intelligence tend to be more sensitive to lifestyle factors, including diet. So that's the kind of test that we hopefully have there. One caveat is, of course, if you've got a really long-term trial over maybe 20 years, a prospective epidemiological trial, then you may potentially pick up some stuff with tests of crystallized intelligence. But those studies are, of course, quite rare. And they all agreed that, of course, paradigm should have validity and reliability as a requirement. And they all made great recommendations for tests that have that. So to me, the areas of disagreement are a little bit more interesting. So the nature of cognitive functioning is that tests tend to measure more than one domain. So a good example here is if you need to recall a number of words, then you first need to, of course, pay attention to encoding those words in the first place. So you can see how this is a memory test, but actually it does measure attention as well. So there's disagreement about how that should be handled. So some suggest using a comprehensive test battery so that you can identify which domains are most likely to be affected. So, for example, you had an effect on the word list, but you didn't have an effect on an attentional task, then you might conclude that these effects are specific to memory. Okay. On the other hand, others argue that we should pick our domains in a theoretically meaningful manner to avoid the risk of false positives. Okay, so we shouldn't really be taking this scattergun approach to it. Interestingly, there are discrepant findings in regard to which domains most sensitive to nutritional interventions. I think part of this is probably because it's going to vary depending on the nutritional intervention, but there's some suggestion that verbal memory might be particularly sensitive, and also spatial working memory came up as being sensitive to measure as well. These papers tend to use different cognitive taxonomies that describe the cognitive architecture. Again, this comes down to the fact that psychology really is an evolving discipline. We don't have a full understanding of cognition. And so people are going to debate about how it should be broken up into memory, attention, executive functioning, etc., and whether or not we should be producing these measures of real-world cognition, and also how they should be produced, was matter of disagreement. So our approach here was to assimilate a group of experts to try and tackle some of these problems that come up in this area and see if we can make some sort of recommendations for future research in order to be able to move this forward a little bit. Right, so I just want to acknowledge members of the group here. Okay, so these were the solutions that were suggested. Basically, in regards to composite scores, it was concluded that obviously this should be done in a theoretical manner, but ideally individual test scores should be reported at the very least in supplementary information. That way, studies are more comparable, even if the composite scores do vary a little bit. The lack of reporting, it was suggested that perhaps in this space, what we need is some sort of guidance or checklist for reporting recommendations. To be honest, I don't think the way that we report tests in the nutrition literature would fly in any other area of psychology. So I think that's probably quite a good suggestion. Unfortunately, lots of really well validated and normed tests tend to be behind a paywall. So it's not uncommon for groups of researchers to make their own bespoke cognitive tests. And of course, if they're going to do that, then they do need to be reported accurately and in sufficient detail so that their validity can be determined. Quite a bit of work, I think, needs to be done in terms of understanding which cognitive tests are most sensitive to nutritional interventions. So there's been a tendency to basically study the effects of diet on cognition, but what we really need to do is hold the nutritional constant and manipulate the cognitive side of things. So give them different tests, change the parameters in the test, change the speed at which it's presented, those kind of things, so that we can better understand how diet might be influencing certain cognitive functions. So this has been done a little bit in regards to glucose, and it does seem to be that verbal memory in particular is more sensitive to carbohydrate-based interventions. But in regards to other nutritional components, this really hasn't been done at all. So that was recommended as a future research direction. Biological plausibility is obviously really, really important. So it suggested that perhaps we should be studying animal research, which does allow us to drill down into the biological mechanisms a bit more alongside human behavior. I would say a caveat here is that reducing complicated cognitive processes down to discrete biological pathways is quite a reductionist approach. And in some ways, that really something that we want to avoid. So the two sides of the coin there, really. There's the suggestion that we should be contextualizing any effects that we get from nutrition, then norms on those particular tests. And that way, it would allow us to determine the effect size of dietary interventions and whether or not this is actually a clinically meaningful effect that we are observing. A major concern, I think, at the moment is that lots of studies that involve cognitive tests are done in the lab, and these tests are born out of cognitive psychology, which is very much a lab-based discipline. And at the moment, we have very limited understanding in regards to how this translates into everyday behaviours and how this marries up with what the consumer might be expecting to achieve when they change their diet or buy a product. So we've been doing a little bit of research on this more recently, and it seems like in regards to memory and attention, there's quite a lot of alignment there. But often, we're not studying the effects that the consumer is interested in. So consumers tend to be interested in sort of prospective memory, which means remembering to do something in the future, as opposed to remembering that you've done something in the past. So unfortunately, in the laboratory, we tend to study episodic memory, which is remembering something that you've done in the past. Okay, so there's a little bit of misalignment with some of these expectations. And finally, we need to accept that the literature to date is as it is, and try and work out whether or not there's anything that can be done to help better synthesize that literature. And this is one thing that we're working on at the moment. So we're looking at developing methods for retrospective harmonization. So these kind of methods tend to involve deducing sort of Z-scores or common metrics across the task so that the performance of the task can be better synthesized, basically. So we're looking to see whether or not those kind of things are indeed possible with the literature as it is. So I've had to move through this quite quickly today, unfortunately, but we have published these suggestions now in Advances in Nutrition. So if anybody is interested in this area, then obviously more detail will be available in the actual manuscript. But just to conclude, the heterogeneity that currently exists in the cognitive test selection in nutrition research is a real problem. And if we are ever going to be able to make dietary recommendations to enhance cognitive health, then this is something that we do really need to come to some sort of agreement on. Basically, at the moment, we can suggest that tests should be objective as opposed to self-report measures. They need to be tailored to the particular population that you're interested in. They need to be sensitive enough to pick up effects of diet. So measures of crystallized intelligence probably are not going to be that sensitive. They need to be reported in sufficient detail so that those tests can be validated, and that evidence can be used. Because if basically when I read the literature, if I don't have that information, then I have to assume that the test is not valid, and that's a shame, because some of these studies that are conducted are large studies over a number of years. Tests should be reported in sufficient detail. And if global cognition scores are going to be used, then in my view, and in the team's view, then all the individual tests should be reported as well. More future research is needed to work out whether or not it is possible to harmonise the data that are currently available. Perhaps develop standardized reporting criteria. We need to start looking into some of these areas that the consumer is actually interested in, like prospective memory, and also determine, the ecological validity of some of the measures that we use in the laboratory. So, do those effects that we see in the laboratory translate into the real world? So I'd like to Swansea University and IAFNS and National Institute of Health for supporting this presentation today.
Excellent presentation, Dr. Young. Thank you so much. And thanks too for sharing that article. So if we could post that in the chat, maybe people will take a look at that. That's really interesting. So now, before I move on, I do want to say that for our audience, you can go ahead and add your questions in the chat as you think of them. You don't have to wait until the end. So now, let's move to our next presenter, Dr. Hussain Yassin. Dr. Yassin is an associate professor in the Department of Medicine, Keck School of Medicine at USC. The Yassin Lab specializes in how changes in lipid metabolism and nutrition affect cognition and the risk of developing Alzheimer's disease. I want to add that his lab has an interest in studying how carrying the ApoE4 allele, strongest genetic risk factor for developing Alzheimer's disease, affects lipid metabolism, the response to diet, and combining basic science, clinical trials, and brain imaging studies. So without further ado, let me turn it over to Dr. Yassin.
Thank you, BJ. Can you see my slides?
Yes, I can.
Okay. Excellent. Thank you for this kind introduction, and I would like to thank IAFNS for the invitation and NIH. Well, today I'm not going to talk about my own research, but mostly about the proceedings from the Nutrition Symposium for Dementia Prevention that was held between 2020 and 2021. And I hope that you find this presentation useful. Let's see how I can move this. All right. I have no relevant financial disclosure. So basically, the question we're trying to address is that systematic reviews of many randomized clinical trials involving the diet and nutrition have largely reported null effects on cognitive outcomes. And as Haley was showing, there's a lot of inconsistencies and limitations. So we assembled an outstanding group of international scientists to address this issue and discussed novel study designs, emphasizing the role of biomarkers, genetic nutritional assessment tools, to translate the epidemiology into more effective interventions and lay the groundwork for a roadmap. We met at least 8 times, and then I had a symposium sponsored by the Alzheimer's Association, and the proceedings were actually published as a paper. This is the paper. I'm happy to put the link in the chat box. The paper was published in 2022 in Lancet Healthy Longevity and summarizes a lot of discussions between the various members. I would like to acknowledge all the individuals that actually met over a period of 2 years to debate various aspects of nutrition, the diet, and the brain. Let me start by disclosing something that we all know. The relationship of the diet with the brain is quite complex. We tend to be reductionistic, and my take from these 2 years of debates and discussions is that we do have to dissect down how the diet works and how it affects the brain. We cannot look in the diet in isolation. There are many other factors which influence how the diet works, not only physical activity, environmental factors, there's genetics. We have to look at the systemic factors, including hypertension, the microbiome, diabetes, and ultimately understand how this affects the brain, and looking at various compartments within the brain, such as vascular inflammation, metabolic, and the AD neuropathology, amyloid tau, and so forth. So the actual symposium was broken down into 4 different themes, and each theme had a specific expertise. The first theme was really an epidemiology theme, and the conclusion of that theme was to move toward diet pattern interventions. This was led by Fran Grotstein, and the group debated diet patterns and concluded that diet patterns such as the Mediterranean and Mayan diet have promising results, and that whole diets capture tiny but possible additive effects of individual foods and the nutrients. And the future roadmap emphasized the importance of doing a network analysis to map the relationship between certain foods and identify new patterns of interest. They emphasized modeling analysis to define the critical window of when these interventions should start, and developing scalable and digital tools to measure diet behavior, especially in underserved population. The second theme was led by Cecilia Samieri and actually focused on biomarkers and precision medicine. And biomarkers are needed to accurately measure the diet, the response to the diet, and nutritional outcomes. These biomarkers are especially important during midlife when cognition is not changing. So the conclusion from Theme 2 group is to identify cost-effective, reproducible measures of nutrition or nutrient biomarkers, integrate the assessment of the gut microbiome to estimate differences in the response to the diet, account for genetic variation, and utilize biomarkers, particularly brain imaging biomarkers, that captures the effect of the diet on the brain. Now, Theme 3 was really related to inconclusive nutritional trials that have been published and what are the lessons that need to be learned. This was led by Nick Skarmeas, and the group debated many issues, but I'm going to highlight really the most important. One is to avoid underpowered trials. The studies in diet and nutrition have been really too short to see a duration effect. The intervention was adapted too late. The groups were quite heterogeneous and were not at high risk for dementia. The outcomes selected were not clear. The supplement dose type and, importantly, nutritional baseline status was not clear. And we are not investing enough in listening to the community so we can recruit and engage underserved population. And that's a science on its own. Lastly, the symposium had a theme designated or focused on designing future trials that are really specific to nutrition and diet and how it affects the brain. And this was led by Lon Schneider. And in this theme, we discussed timing is really important for interventions. And in this regard, a 5-year window supported by NIH may not be sufficient to look of how a diet can actually influence the brain. Often we're modeling epidemiological studies that take so much time. So we talked about risk stratifications, using biomarkers, capturing nonlinear relationships, modified trials such as cluster and randomized stepwatch designs, protracted passive run-in period to identify compliance, had adaptive designs to allow changes before randomization, understanding the mode of action of nutrients so that we can actually, match the outcome to how the diet works, and utilizing e-health to scale up interventions. Okay, so I talked to you about the proceedings of the nutrition symposium. Now, the last 10 minutes, I really want to talk to you about what happened in the MIND trial, which was just published last month. And the following section of the presentation does not reflect either the funders, Alzheimer's Association, NIH, nor the committee for the nutrition symposium. It only reflects my own interpretation. So I do not want to say something that's not accurate. This is my own interpretation, and it's not endorsed by any other entity. So you might have been following the news, and you might have noticed that we were all excited to learn about the MIND diet, and it was recently reported in the New England Journal of Medicine. So the background for the MIND diet, this is led by Martha Claire Morris and colleagues at Rush and Frank Sachs at Harvard, was really based on this epidemiological follow-up of the MAP, the Memory Aging Program at Rush, which followed people up to 10 years and found out that people on the highest tertile of the MIND score, and we'll talk about the MIND score in a minute, had better global cognitive scores than those in the lowest tertiles of the MIND score. And just to show you a little bit, the age was around 80. If you compare the first tertile to the third tertile, you notice that, as you might expect, those with a better MIND score were more physically active, and the BMI was approximately 27. So then the MIND population was designed, the MIND trial population, and they started looking at patients between 65 and 85, had a BMI more than 25, had a MIND score. They excluded people with a MIND score greater than 8, and they had required a family history of dementia. Approximately 600 people were randomized into the placebo versus the MIND arm. So these are the baseline characteristics. I want you to take note of the age, 70 years of age. About 88% of those individuals were white, and the body mass index had a mean of 34. And the MIND score is about 7.7 or 7.8. So talking about this population, they started this intervention at the age of 70. That's much later in life. The mean BMI was 34, which meant that this is really a population of obesity. The majority of these people were white, 17 years of education, that's an educated population, and a baseline MIND score of 7 suggested that these are not very poor diets. They're in the middle between, the first and the third tertile. So the intervention raised the MIND score diets from 8 to 11. And if you look at what the epidemiology shows, this is really the first two groups, the MIND score high and MIND score mid. And it's the first 3 years of this follow-up, if we can just mimic what happened with the epidemiology study. And of course, as if you've seen the paper, there's actually no effect whatsoever of the MIND diet compared to the control on global cognition. The investigators interpreted these changes as both interventions improved cognition, but arguably this could be a practice or a learning effect. We don't really know if this is an improvement or a practice effect. Now, more interestingly, both groups were counseled to lose weight and successfully lost 5 kilograms. So the strengths of the MIND trial really is that they used a whole diet as opposed to single nutrients or supplements. And I think this is quite a significant advancement in the field. They were very successful in recruiting, and they had a very high follow-up rate. And impressively, both arms lost 5 kilograms. Now, I'm just going to tell you my own interpretation, and hindsight is 2020. But if we were to redo the MIND trial, how would we do it differently based on the discussions we've had and the symposium for a nutrition symposium for dementia prevention? Well, first, the intervention started at the age of 70, and we know that epidemiology reflects really lifelong exposures, and this may well be too late and too short to affect cognitive outcomes. The two groups were not very different after the intervention, and they both became mind-like. The study was not powered to see small or medium-sized effects. In fact, even if we look at the power calculations, they were anticipating large effects. The population had obesity, and this was different from the original MAP study, which had a BMI of 27. Weight loss may have had a stronger effect and masked the mind intervention itself. And we do have to entertain the possibility that the null hypothesis is true, and the mind diet may not have an effect on the brain, but confounds other protective risk factors. So those who have a higher mind score may just be a healthier population that exercises more, and not necessarily the mind diet itself. So how do we move the field forward, and how do we dissect the effects of the diet on the brain to get more informative trials? In the actual proceedings, we really spent some time on two approaches that can actually fix this. One is a personalized approach, and one is a population approach. And I urge you to go into the paper to understand much more what these two approaches mean. So let's redesign the mind trial and the personalized approach. In this case, we would start early in midlife, modeling epidemiology that suggests that midlife is when the diet really has the strongest effects on the brain. We would select a population with lower mind scores, and I know this is a challenge, but we need to work on this. And we would be focusing on underserved populations, which would have worse dietary patterns. We would use brain biomarkers that capture how the diet works, as opposed to cognitive outcomes, because cognitive outcomes might take many, many years to change, and they're less informative in midlife. And short-term trials may not change cognitive outcomes meaningfully. And finally, we would need to incorporate biomarkers to capture the baseline nutritional status, the compliance, and integrate the microbiome to understand what's happening with the diet. Can we design the mind trial in a different way from a population approach? Yes, we can, but it will be quite different. Here, we would include a much larger sample size, powered to see small effect sizes, because we think the diet's effect on the brain are not going to be huge. We would have to select a vulnerable, underserved population now, and we wouldn't be nitty-gritty picking mind scores, but utilizing scalable nutritional status biomarkers. We should be using a multimodal intervention, for example, combine the diet with exercise. We would be using pragmatic outcomes, and the intermediate outcomes can include blood pressure, diabetes, weight control. So after the intervention in this population, we would get a readout that the blood pressure improved, that the diabetes improved, that the weight loss happened. To us, that would mean that the intervention was successful. And then long-term brain outcomes would be planned over more than 5 years and really focus on how the diet works. For example, there are studies suggesting that executive function might be more amenable to a dietary intervention than memory outcomes. So we really need to understand how the diet works as opposed to using generic, global, or outcomes that reflect Alzheimer's disease as opposed to nutrition and the brain. So I want to acknowledge the organizers, including Heather Schneider from the Association, Christina McClendon from NIA, and others who've worked on organizing. This was funded by an R13 mechanism from NIH. And thank you for your time, and I'm happy to take any of your questions.
Thank you, Dr. Yassin. Very interesting presentation. Our audience may have noticed that we have posted the paper Dr. Yassin referenced in the chat. And please feel free to post any other references in the chat for the benefit of our audience, Dr. Yassin. I know you've referenced to other papers, and thanks to for sharing those insights about redesigning the mind trial. That's really interesting. So we'll take the questions at the end. We have one more presentation to go. And let's move on to our third speaker. Our third speaker is Dr. Suzanne Summer. Dr. Summer is a research associate in the NIH Clinical Translational Science Award affiliated research clinic at Cincinnati Children's Hospital Medical Center and the University of Cincinnati. She's a registered dietitian and oversees the clinic's nutrition research support services, where she has used and advised on nutrition methods in clinical research as a key collaborator on more than 100 experimental and observational studies. So, Dr. Summer, tell us, what we heard all about it and how can we use it? Where are we now? Thank you.
Okay, great. Thanks for that introduction. Can you see my slides okay?
Yes.
Okay. So I have no disclosure, and I'm excited to be involved in this. I'll admit I'm a little nervous. This isn't directly my field. I'm a dietitian working in research, but I've had the opportunity to work on some of these studies with other collaborators. And on a personal note, this topic is of great interest to me. So now that we know the limitations of current research in this area, I want to talk about what do we know about brain health and preventing cognitive decline. So first, what do we mean by cognitive health? According to the Consumer Perspectives study published by IAFNS, this phrase usually means one of two things to people. Either brain or cognitive health for adults at any age, meaning having optimal focus, memory, and function, and minimal anxiety, or cognitive decline, which we typically think of as related to aging, such as mild cognitive impairment and dementia. Just as a note, I don't know if it's been brought up before, but mild cognitive impairment is generally defined as having cognitive changes serious enough to be noticed by the person affected and maybe family members, but don't affect your ability to carry out everyday activities. Whereas dementia is an umbrella term defined as declining cognitive ability severe enough to impair daily life and function. Now, since we know from Dr. Yassine's presentation that prevention really needs to begin in midlife, it makes sense that the recommendations for maintaining cognitive health, which is a concern for a lot of middle-aged adults, and preventing decline go hand in hand. So from here on out, my presentation will focus on preventing decline, but the same principles can be applied to both. Despite what you might see in TV ads or sensational headlines, there is no cure for dementia. Lately, we've been hearing about some very promising treatments for Alzheimer's disease that give us hope, but there is no cure, so we really need to focus on prevention. There are several known factors that make a person more or less likely to develop dementia, and some of these are non-modifiable, meaning we can't change them. First, while dementia is not a normal process of aging, aging and age-related changes in the brain, like shrinking, inflammation, and blood vessel damage, can increase the risk for developing dementia. Another non-modifiable risk factor is genetics, wherein if you're a carrier of a specific gene variant, that might put you at a higher risk. There are gene variants that put you at a lower risk, but unfortunately, those are quite rare. Interestingly, and I just learned this recently, Down syndrome is another risk factor for dementia, and specifically early onset Alzheimer's, because there's an extra copy of chromosome 21, which is what carries the amyloid precursor protein, which is related to development of Alzheimer's. But the good news is research has identified risk factors that are modifiable, and those are our best shots at prevention. So the Lancet Commission 2020 report on dementia prevention, intervention, and care lists 12 potentially modifiable risk factors for Alzheimer's and dementia. And note that these are based on global data, so they're not just specific to the US or developed countries only. Diet is not included as a modifiable risk factor here. However, you can see that several of these have a strong nutrition and lifestyle component that are influenced by diet, such as minimizing diabetes, treating hypertension, reducing midlife obesity, and maintaining frequent exercise. So in my next few slides, I'm going to look at some of the compelling evidence that supports a role for nutrition and lifestyle habits. And bearing in mind what we just heard from Drs. Young and Yassine, I tried to focus just on studies that are observational and not so much intervention because of the limitations in study designs therein. But still, I do want to talk about some of the evidence that's out there. So first, a review by Scarmius in 2018 summarizes the evidence for single diet components. Some examples are B vitamins, and these are all from that paper. B vitamins, antioxidants, vitamin D, all having a role in preventing cognitive decline. Omega-3 fatty acids,
And there's some newer studies arising that look at individual foods such as nuts, berries, and now ultra-processed foods and their associations with development of cognitive decline. As has already been stated, results from these studies are mixed, and the evidence isn't strong due to those study design issues and some confounders present. What we need is long-term exposure and low initial intake to see some effects. And the good news, again, is that stronger evidence does exist for dietary patterns because they have the benefit of showing a cumulative effect of combined diet components. So I'm going to review some of the big ones, and I'm going to wrap up with what is ultimately recommended for prevention. Okay, the Mediterranean diet was initially characterized based on cultural practices in this region of the world where chronic diseases such as heart disease and stroke are relatively low. This is a plant-based diet that limits red meats and sweets, recommends dairy and poultry, and eggs just a few times a week, fish 3 times a week, and most plant food sources daily, such as whole grains, legumes, fruits and vegetables, and unsaturated fats, including servings of nuts. Talk about a couple of the big studies that we're familiar with. PREDIMED was a large multi-site trial in Europe with over 7,000 participants. It was a randomized controlled trial designed to compare the Mediterranean diet versus a low-fat diet as the control, and it was designed for cardiovascular disease prevention. But as with most large cohort studies like this, they collected other data as well, including some cognitive measures. So in the PREDIMED Novara trial, they analyzed data from the different diet groups and cognitive outcomes of 522 adults at high vascular risk. And after 6.5 years, they found that cognition improved for those on the Mediterranean diet as compared to those on the low-fat diet. A meta-analysis by Wu and colleagues, pulled data from longitudinal studies of people followed between 2 to 12 years and measured their adherence to the Mediterranean diet. This study comprised nearly 35,000 individuals. Outcome measures were incident Alzheimer's or dementia, and they found that a higher Mediterranean diet led to a 40% reduction in risk. And finally, the European Prospective Investigation into Cancer Nutrition, another large cohort study, also collected data on cognitive measures. In the Epic Norfolk study, there were older adults in Great Britain, and they were followed for 14 years. The study measured their adherence to a Mediterranean diet in the 90s, and then measured cognitive performance 14 years later, and found that early high adherence to Mediterranean diet led to an average of almost 2 fewer years of cognitive aging. In other words, a slowing of cognitive decline for those adhering to that diet. And now for the DASH diet. DASH was initially developed to treat and reduce primary hypertension. So where it's similar to the Mediterranean diet is that it emphasizes vegetables, fruits, and whole grains. It limits foods high in saturated fat like fatty meats, full-fat dairy products, and most oils, and it limits sugar-sweetened beverages and sweets. The differences between these two diets are that the Mediterranean diet limits dairy and emphasizes olive oil, while DASH does not. DASH is pretty restrictive on amounts of sodium and all fats, including from nuts and oils, and all meats, including fish, while the Mediterranean diet emphasizes nuts as a good source of unsaturated fatty acids and encourages fish 3 times a week. Both diets are restrictive in terms of red meat and sweets. There are just a few big studies that have looked at evidence for the DASH diet in relation to cognitive decline. In 2016, results were published from the Women's Health Initiative mental study where 6,400 postmenopausal women with 9 years of follow-up were examined. Pre and post testing with the DASH score calculated from food frequency questionnaire results showed that those with the highest DASH scores were associated with 28% lower MCI. Again, that's the mild cognitive impairment risk. However, the diet was not associated with incident MCI or probable dementia. Another study, ENCORE, U.S. Exercise and Nutrition Interventions, again for cardiovascular health. This was published a little while ago. This was another randomized controlled trial of DASH diet effects on cognition. It was fairly short term, so we know we need longer term studies. what I wanted to point out about this study, which mimics or repeats what Dr. Yassine had said, is that the main results, so they had 3 arms. They had DASH diet alone, DASH and weight management, which included calorie restriction and exercise, and a control group. So there was 3 groups. The psychomotor function improved with DASH and DASH plus weight management. And interestingly, though, executive function, memory, and learning all improved with the DASH plus weight management, but not with DASH alone. So again, that's throwing some of those confounders in there. And this all brings us to the MIND diet. So the MIND diet has 15 dietary components, including 10 brain-healthy food groups, like green leafy vegetables, other vegetables, nuts, berries, etc., and 5 unhealthy groups, such as red meats, butter, margarine, cheese, pastries, and sweets. Notably, berries are the only fruit listed on the MIND diet due to their protective effects on brain health, especially blueberries. Just a little background on how the MIND diet came about. So Martha Claire Morris and her team developed the MIND diet based on evidence that we've already gone over for the Mediterranean and DASH diets for slowing cognitive decline, though neither of those diets were designed for this. So their rationale was that the Mediterranean diet reflects a culturally based diet pattern, and DASH was devised to reduce blood pressure. So neither diet was specific to our current knowledge on neuroprotective foods and nutrients. So again, MIND is similar, emphasizes natural plant-based foods and limited intakes of animal and high saturated fat foods like the other 2. But MIND uniquely specifies consumption of berries and green leafy vegetables and does not specify general high fruit consumption, high dairy, or greater than 1 fish meal per week. In their 2014 abstract, Morris and colleagues computed the 3 diet scores with 915 participants who were followed for nearly 5 years, and they each had at least 2 annual cognitive assessments over those 5 years. They found the MIND score correlated with the other 2 scores, and the MIND diet pattern was a better predictor of cognitive decline than Mediterranean or DASH. Okay, I know this diet is controversial. As a dietitian, believe me, I know that. I want to touch briefly on it because it has an interesting theoretical basis for contributing to brain health, but not a lot of evidence yet that it's effective in preventing decline. So one of the challenges facing the brain as we age is somewhat deficient uptake of glucose. Cognitively healthy older adults have about 7 to 8% lower brain glucose uptake than younger adults, and this is further reduced in MCI and dementia. Imaging studies have shown that unlike glucose, uptake of ketone bodies by the brain for energy is stable during aging and with MCI and dementia. So some refer to this as brain energy rescue, which is associated with improved cognitive outcomes in both MCI and dementia. Just a note, so the studies that found this or that studied this used either a very low carbohydrate ketogenic diet or 20 to 30 grams a day of ketone-inducing MCT or medium chain triglyceride supplement to generate ketones to study this. Another thing to note is that a ketogenic diet could also have indirect effects on cognitive health through its effects on other metabolic markers such as improvements in insulin resistance, body weight, lipids, and glucose. But again, there's limited evidence on the effects of a ketogenic diet for cognitive improvement. The studies are small sample sizes, interventions are brief and vary a lot across studies. So while the theory is intriguing, there's not a lot of robust evidence yet. And they need larger trials, again, with homogeneous diet composition and longer interventions. Just gonna check how I'm doing on time. Now, from a public health standpoint in the US, we look to the Dietary Guidelines for Americans, which are released every 5 years and are intended to synthesize the best available evidence to develop diet recommendations that promote health. For the current 2020 to 2025, the DGA is summarized here. And Guideline 1 is follow a healthy dietary pattern at every life stage. So what does that mean? Well, the DGA recommend a general USDA healthy eating pattern that can be customized to cultural and budgetary needs and preferences and offers a lot of resources to do that. So here, this is a consumer-friendly infographic, and here's where the Dietary Guidelines for Americans, or DGA, are translated for consumers by outlining general diet pattern guidelines. And the guidelines are then operationalized through the USDA Healthy Dietary Pattern, which incorporates a lot of fruits and vegetables, whole grains, protein variety, low-fat dairy, low sodium, added sugars, and saturated fat. So while it's a little more general than the Mediterranean or DASH recommended dietary patterns, you can see that the guidelines still follow a similar pattern in terms of what to eat more of and what to eat less of. So you're starting to see a pattern among these different dietary patterns. And I want to just point back to, though, what Dr. Young had pointed out, which is that the Dietary Guidelines Advisory Committee discusses the limited evidence, and they sort of stop short of targeting specific diseases or conditions such as cognitive health or cognitive decline because of, quote, the considerable variation in testing methods used. Am I doing okay on time?
Yeah.
Yes, you're fine. Okay, thank you. Before summing up, I want to touch on exercise. We can't dismiss exercise, right? So theoretically, exercise may have a direct effect on the prevention of cognitive decline by increasing blood flow and oxygen to the brain. But exercise, like nutrition, may also have indirect effects by helping to manage or reduce the risk for comorbid conditions that are associated with dementia, such as diabetes, insulin resistance, hypertension, and obesity, and other cardiometabolic conditions. So since each of these are modifiable risk factors for dementia, exercise is a crucially important, at least intermediary, that could lessen or cancel out effects. Just a little bit on exercise evidence. Observational studies have repeatedly shown that aerobic exercise, so they don't talk too much about strength training and stretching and yoga type of activities, but aerobic exercises reduces dementia risk, particularly moderate to vigorous exercise. Studies found that physical activity is associated with improvement in cognition among healthy adults, which is important because, remember, we want to look at those in midlife to prevent cognitive decline. And it may also improve executive function and memory in those who have mild cognitive impairment. Physical activity also enhances independent functioning and psychological health, which, while that doesn't directly affect cognitive health, it plays a positive role in a person's mental health and quality of life. And by that, it may indirectly have benefits for cognition. However, as you won't be surprised to know, studies of physical activity in those already diagnosed with dementia have not found benefits. And this is really important. Exercise is likely most effective when sustained over long periods of time. I guess that same could be true for diet patterns, and near to the time of risk. So in other words, if you are a gym rat or you exercise a lot in young adulthood, if that's not sustained, it's likely not protective. I am going to just summarize here and skip to my last slides in the interest of time, but a few folks have figured out we're going to do these multimodal interventions, and that's putting everything together. So it's putting together diet, exercise, other interventions to see if once you put all these together, do they work? In this particular study, they reviewed data from 2 longitudinal cohorts and gave people a healthy lifestyle score where you get a point for doing all the right things. So not smoking, doing regular physical activity, etc. And what they found is that those with a score of 0 to 1, those with a higher score, 2 to 3 or 4 to 5, had a much lower disease risk compared to those who scored a 0 or a 1. I'm not going to talk about the finger study, but I can go back to that later if there's time. What I want to talk about to wrap up is implementation. So it's great that we know all of this, but as a dietitian, my concern is how do we reach the population at large? So these are just my thoughts on the who, where, and how of implementing these dietary recommendations. So who do we want to reach? Since our evidence only supports prevention rather than cure or treatment, we do really need to reach people before decline begins. Midlife or even younger adults, particularly those who are have known risk factors, are the target audience. And also, since they say 80 is the new 60, right? Adults who are living independently, older adults, but don't have symptoms of MCI or dementia should also be targeted for education. And importantly, implementation should attempt to reach all levels of income and education and cultural backgrounds and geographic locations. So where would such intervention or education take place? Well, unfortunately, we know that our healthcare system isn't designed for prevention, so likely this is not going to be something that insurance or Medicare is going to pay for. So those with means could opt to pay for private counseling with a dietitian. Beyond that, primary care seems like the most logical place to begin, with lifestyle education as part of routine wellness checks, perhaps. But I think that group settings might be the optimal venue for basic and ongoing education. Community health settings are centers where groups gather for things like nutrition education, cooking classes, and group exercise. I think this type of setting has the advantage of being close to where people live, with the added bonus of that built-in peer support from members of the group, and that, you know, people are always going to be coming back to the group. Lastly, how do we educate about these lifestyle approaches and encourage adoption? So I want to point out that one of the most valuable aspects of focusing on overall dietary patterns rather than specific foods and nutrients is that they aren't cut and dried, and they really lend themselves to customization. So when it says to eat a lot of whole grains, that could mean wheat bread and oatmeal, but could also mean like farro or couscous or whole grain tortillas or brown rice. Lean protein is chicken breasts, but it's also several kinds of fish, soy protein, egg whites, things like that. Fruits and vegetables can come from the grocery store. They can come from farmers markets or your own backyard. And they're generally just as healthy, purchased fresh, frozen, or canned. I have an asterisk by canned, but you get the idea. And I think a healthy diet should be attainable regardless of income, culture, or language or education. Next, we need to be aware that we have great resources. The USDA has myplate.gov, and if you haven't gone there, I highly recommend you go there. It's really simple guidance for healthy eating based on the dietary guidelines. There's an app or a product, I guess, called My Plan with menus and recipes that you can tailor to your preferences and needs. It can be budget friendly if it needs to. It can incorporate different cultural foods that people are looking for. There are other web-based resources that are also available for following the other diets mentioned today. And of course, there's also fee-based services that are widely available. There's not a nationally sanctioned diet for prevention of MCI or dementia. All these different organizations recommend more or less what we've talked about today, but there's not one diet. So lastly, I want to say, and whenever I'm talking about lifestyle changes, I'd love to close with this important bit of insight. Let's face it, long-term diet and exercise adherence is poor. The perfect prevention diet will not work if it's not followed. A recent meta-analysis found that adherence and weight loss intervention was about 60%, and that's in a research study, so you can imagine that in the general population, it's probably much lower. Factors that promote adherence are regular supervision and social support, and in general, diet adherence is better than exercise. So about 12 years ago, Gardner and colleagues published a paper comparing 4 popular diets for weight loss. And they were hoping to find which diet is best. But after 1 year of dieting, the folks who lost the most weight within each diet group were the ones who had the highest rates of adherence to that diet. So it wasn't so much about the type of diet as it was about the person's ability to stick to it. So with all of that said, what I would say is that the best diet for cognitive decline synthesizes all the elements we've talked about today, incorporates exercise, and most importantly is the one that you or your patient can follow. And thank you very much. I will join in for questions.
Thank you, Dr. Summer. Excellent presentation. So, very practical guidance, and especially for those who are looking from a practice perspective. And I'm glad to see that implementation slide on who, where, and how. That's really, sums up on all the messages that you've given. And obviously, I'm also happy to see that your mention about My Plate guidance, and definitely you can start from there and to be able to start eating healthy. Wonderful. And all in all, it's really, we heard great presentations about latest science on practical applications and what other research that's needed in this nutrition and cognition area. So now I would like to, welcome all our speakers back on the webcam to take some audience questions. Audience, please go ahead and type any of those questions you have in mind. We already have lots of questions. So let me go ahead and start, some questions. I want to start with one that I have in mind, and perhaps all of you or any of you can answer this question. So there's a lot of attention to methods that involve artificial intelligence to make sense of large volumes of data. So are there any possibilities for application of artificial intelligence in this space to better understand risk factors for cognitive decline, including nutrition-related factors?
I can possibly answer some of that question.
Sure.
So there is a rapidly evolving field in spatial navigation, digital sensors, GPS data that can actually model brain function, particularly early midlife to before dementia develops, and that's being at the forefront of research in many countries, including England, the US, and others. So yes, there is tools to actually model cognitive functions using intelligent data. Also, nutrition-wise, there are tools being developed now to actually scan receipts and compute people's diet without having questionnaires. There are tools with a finger strip, you can actually do a veggie index to figure out how much veggies people are eating. So yeah, we are moving into a more scalable, digital-friendly environment where we can go away from pencil and paper cognitive testing and replace traditional tests with AI and digital tools.
Excellent. Thank you for pointing that out. And definitely there are tools available for us to follow up on what we've been doing and what else we could do. It makes that easy. So I see a note here from audience about nutrition education for older adults is provided through Older Americans Act senior nutrition programs. Yes, thank you for that note. My next question is for Dr. Summer. How practical is it to implement the MIND diet to different populations with diverse cultures? That's a big challenge, right?
For sure, yeah. It's always a challenge. This is where I think the beauty of dietary patterns comes in, because it talks about general food groups and it doesn't hold you to specific foods. So I think if you are the private practice dietitian in particular, and I encourage it that if it's not a dietitian that asks that question, that you work with a dietitian, because we do specialize in working with our patient population. So if they're in that population, they know that culture, they can help point them to what foods that they can eat or that they prefer to eat will fit in the different food groups defined by the MIND diet. So again, they limit the fruit intake for the MIND diet to mostly berries, but all the other options, you need an expert who's familiar with that culture and the patient who can work with them to slot their preferred foods into the different recommendations.
Excellent. That's true, right? And you do need to be able to talk to somebody who is able to connect with that culture. Next question is, this is for either Dr. Summer or Dr. Yassin. What strategies are used to better meet the needs of study clients seeking special diets? Kosher, halal foods, or those with seafood allergies, etc.
And I don't want to sound repetitive, but again, a lot of dietitians who are familiar with their own patient population will be the best people to guide people. I mean, there are people who specialize in working with patients who eat halal foods, eat kosher diets, who can really best help them. And there's resources out there, but I think the best thing is to have someone one-on-one who can really help you work through what fits where.
Sounds good.
Sorry to cut you off, Dr. Yassin. I don't know if you...
No, I agree. Thank you.
Sounds good. Let's see. Let's get to the next question. Culture is definitely important, and especially those who know about the culture, and that's really the key. This question is for all the speakers or anyone who likes to answer. What is the evidence of microbiome role for preserving cognitive health? Could pre and probiotics make a difference in risk of cognitive decline?
I can possibly answer part of that question. I don't think we know. My understanding of the microbiome is more toward understanding the response of the diet as opposed to having a direct effect. The microbiome can reflect what people are eating and how they respond to a specific diet, and perhaps may have a direct effect on the brain itself through neuroinflammation, but this is still a theoretical construct. But it can give us a snapshot in time of, a chronic diet, how it remodels the trillions of bacteria that live in the gut.
Thank you. There's a lot of work that still need to be done. My next question goes to Dr. Young. How can Dietary Guidelines Advisory Committee overcome the challenges in this field to arrive at some kind of dietary guidance that support cognitive health?
Well, yeah, I mean, I think we have to accept that these trials are expensive, they take a long time, and the chance of that changing dramatically ahead of 2025 is not strong. So at the moment, we're doing some work to do with retrospective harmonization. So I'm not an expert in the algorithms that are used for that kind of thing, but it's possible that we might be able to make some sort of recommendations for how performance of particular tests should be integrated. And if that's successful, we are hoping that will be useful to the Dietary Guidelines Americans Committee moving forward into 2025. So we'll see what happens there.
Great. Thank you. Thank you for that insight. Next question is Dr. Hussain or Dr. Samara. Within the MIND diet are the specific nutrients that might be especially responsible for the observed effects. I think we talked a little bit about it, but maybe if you could read.
What's the question? What are the specific nutrients?
Within the MIND diet, are there specific nutrients that might be especially responsible for the observed effects?
So, we did touch on, there has been research on some single nutrients. I think probably the best studies have been omega-3 fatty acids, EPA, DHA, and ALA. I think some of the vitamins, some of the B vitamins, vitamin D. Again, the important thing about the diet patterns is it's a cumulative effect of a number of these nutrients. And so we try to avoid honing in on one nutrient because you don't want to just consume all of this one nutrient and then avoid everything else because they all work in concert. But those are the ones I know of. And also polyphenols and some of these, what's the term, like functional nutrients are also high in those diets.
I would add to what Dr. Summer said. It's not just the good nutrients that you're eating, but also avoidance of the less healthy nutrients that you should not be eating. So it's a combination of.
Exactly. I think the focus on the whole diet is the key here, right? It's just not one thing or the other. We have a similar question. Since adherence to healthy eating is difficult, can the speakers comment on supplementing the diet with vitamins and minerals or other dietary constituents to help in preventive care? I know this is a really common question. So when you go to the doctor, what do they prescribe, for either prevention or management of Alzheimer's? So, what do you think?
Maybe I can take the first stab. One of the things we addressed in the nutrition symposium is this question, and the committee concluded that we need to address nutritional status because not everybody needs to be taking supplements and vitamins, and these are some large industry that's trying to advocate for their consumption, but there are specific populations which are nutritionally deficient. For example, if they have a high homocysteine level, they may benefit from a vitamin B12 to lower homocysteine. but that shouldn't be across the board. Everybody should be taking vitamin B12. And then the committee also said that we don't really know much about doses, frequency, and duration, and more specific, studies are needed to gather this evidence before recommendation.
Wow, that's really interesting. So even so, I mean that's a good point, right? We really don't know at this point. And what about the omega-3 fatty acids? Would you apply that to the same guidance to that, or do we have? I asked this question because fish eating is good, but those who are not able to and they take omega-3 fatty acids, and does that help at all, or we're not? I think not quite there yet.
So this is an area where my lab works on, and I would say that we don't know. I would also emphasize that people with a lower omega-3 index may benefit more than people with a normal or high omega-3 index, and this is a measure of the omega-3 nutrient status in blood. But despite that, there hasn't really been direct studies which took people with low omega-3 index, increased it, and showed direct effects on the brain. It also could be a confound for a better nutritional status per se. So despite the appeal and despite the epidemiology studies, we don't fully understand whether a single nutrient like the omega-3 can stand out. Of course, it could, but larger population studies in those groups that would really benefit from such an intervention could shed insights whether that's the case or not. One example, we study ApoE4, which is the strongest genetic for risk factors, and our study suggests that E4 carriers who do not consume enough seafood or with a lower omega-3 index are at a greater risk of getting dementia. Does that translate that supplementing would actually decrease the risk? We don't know. We're actively doing studies to figure this out.
Good to hear that. But when you said that, the first question that comes to my mind is, how do I get my index checked? Can I go to my doctor and ask what is my omega-3 index? Maybe we're not there yet. I don't know. I'm asking this on behalf of audience and my mind.
Go ahead, Suzanne. But yes, it can be checked. Quest has a tool. Other labs have a tool. Right now, there are labs which can provide this information.
I see. Thank you. Okay, let me see. We have lots and lots of questions here. I'm doing my best to get a representative list of questions. Question for Dr. Young. Given all the complications of test selection and administration, it seems difficult to evaluate the literature as a non-expert. Do you have any recommendations for how to evaluate studies that use a cognitive performance test?
Yeah, I think this is probably going to come from both sides. So lots of the papers that I discussed in my talk would be a good starting point for identifying what is actually a valid or reliable cognitive test measure. But I also think that scientists, when they're writing manuscripts, could do a better job of emphasizing why particular tests were chosen, and providing evidence that they are sort of reliable and valid tests and relevant to that particular population. So I think that, it's got to come from sort of both sides here, really.
Thank you. That's helpful. Next question. I know we're getting close to time. I'll put in, as many questions as I can. Questions for Dr. Hussain. If a multimodal intervention with diet and exercise is necessary for dementia prevention, is there no need to determine the individual effects of diet and exercise? Is the assumption that both are equally important? I think we covered this to some extent, but I'm going to let our experts answer this.
Oh, that's a great question. I don't know whether you could say the diet is more important than exercise or the other way around. And I think at a global population level, we should emphasize both. At an individual level, I think that there are new technologies and information that can customize a certain intervention based on the dietary pattern or the physical fitness and so forth. But I wouldn't say that exercise is more important or diet is more important. I would say we have to be holistic and look at both.
Yeah, I would say that there's probably an interaction effect there, where people who do a lot of physical activity are likely to have different dietary requirements as well. So the two things sort of go hand in hand.
Okay. For now, we just had to be careful about both. Yes, it's good for not just for, cognitive decline, for overall health too, right? So, I think we just have time for only one more question. I see that. And so I think you talked about omega-3, but another question here is, what are the valid biomarkers that can be used in clinical trials that are associated with cognitive health? Are there any other biomarkers? Dr. Hussain, maybe?
Yes, there are several biomarkers that are either in development or seem to be promising. I mean, we mentioned the omega-3s. We also have homocysteine as a marker of vitamin Bs. You've got 25-hydroxy vitamin D. You've got, we have, if it's helpful, I could put in the chat box a link to a paper we've published that has a big list of biomarkers that can be used to assess nutrition. There's also imaging biomarkers. We can image fatty acid brain uptake. We can image blood flow. We can image connections in the brain that can respond to a diet. There's a lot of biomarkers that can be done to capture how the diet works.
Excellent. Excellent. Please put that link in the chat, Dr. And that'll be really helpful. Well, I want to take this time to thank all of our speakers. Great presentations, and thank you for answering all the questions. And I feel like we've learned a lot about the science. And at this point, I would like to turn things over to Marie. Sorry, Marie, we're almost close, just 3 minutes. We could go on for another 10 minutes with all the questions.
That is true. No, perfect timing. So just wanted to thank you, Brahma, for moderating, and a huge thank you to our speakers, as well as those in the audience who gave us the great questions. And a reminder for those who are seeking the continuing education certificate, we'll give you that access after the webinar. Please take a look at the IAFNS website, including the work of our Cognitive Health Committee that brings you this webinar today. And we look forward to seeing some of you at our future events. So thanks, everybody, and have a great rest of your day.
Thank you.
Bye-bye.